Hi guys, so today we're going to look at simplifying radicals. So this is something that you're going to use more on next class when we start solving more quadratic equations. So simplifying radicals is basically when you're taking the square root of something, we're going to look at how do we simplify it, how do we work with it, because you're going to start seeing a lot more problems that have square roots as well as a method that we're going to learn next class. So today is really just focusing on the simplifying part of it. So the first thing here, this opening exercise, just to simplify these, so basically just take the square root of 16. So it's asking you what times what will give me 16. So that's going to equal 4. Square root of 49. So what times what gives me 49? Well, the answer is 7. And then square root of 100 is saying what number times what number gives me 100, and it would be 10. And notice it's got to be the same number being multiplied by itself. So 4 times 4, 7 times 7 gives me 49, 10 times 10 gives me 100. There's also a square root button in your calculator that you could use as well to evaluate these. So the next part here is asking you to make a list of the factors. So remember, factors just mean what numbers multiply to 72. So we can start with 1, so 1 times 72 would equal 72. 2 would be the next one, times 36. 3 times 24. 4 times 18. 5 doesn't go into it, so 6 and 12. And then 7 doesn't work, but 8 and 9 would work. And then once we get here, the next number would be 9, which we already have, so it starts to repeat. You guys can do the rainbow for this if that's what you want, but mainly you just got to get the factors. So here's the numbers that multiply to give me 72. Now, if you look at the next question here, it says, are any of the factors listed perfect squares? So this is what's going to be important for today. Being able to come up with the factors, but then knowing which ones are perfect squares. So remember, perfect squares, just to kind of give you a quick refresher here, are whenever you square a number. So, for example, 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 5 squared 25, 6 squared 36, 7 squared 49, 8 squared 64, 9 squared equals 81, and 10 squared equals 100. And you can keep going with this, but these are probably your most commonly used perfect squares. So the perfect squares are the results from the number being squared. So the numbers over here on the right side, these are all the perfect squares. So if you look, if we compare this list of numbers right here, 1, 4, 9, 16, 25, 36, over to my factors, which ones are perfect squares? Well, 36 is a perfect square. So 36, 4 is in that list, and 9. And that's it. So those are the only 3 perfect squares. Now this is going to be important in a minute. We're going to use these perfect squares because they're factors, and we're going to use them to what we call simplify the radical. So just kind of hold on to that thought for a minute, and let's just do one more example of coming up with the factors and then identifying the perfect squares. So when we look at coming up with the factors of 48, again, 1 and 48, go to 2, 2 and 24, 3 and 16, 4 and 12, 6 and 8. So those are all the numbers that multiply to give us 48. So then looking at these, are any of these perfect squares? Well, compare these factors with the numbers over here. So if I scan through here, I see 16 and I see 4 as being perfect squares. So instead of having to go through and actually think about all the numbers that multiply to 72, multiply to 48, and list them out, what you can do is you can, in the calculator, if you go to the graphing section, you can type in f1 of x. Well, that's like when you hit tab, that's your entry. You can just take and type in 72 divided by x, and that will give, and then go to the table. and that'll give you the list of all of your factors. So you can try that to see if you get these same numbers. So, and look at table. So if you didn't want to have to list them out, you could just go and look in the table, and that could work as your list. And then being able to identify the perfect square is going to be important in a minute. So same thing with this. If I were to type this into the calculator, I would go into the function where you enter. So hit tab in the graph screen. And then you would do 48 divided by x, and then you look in the table, and again, these numbers should appear. Now, the calculator will give you decimals. So for example, 5 doesn't go into 48, but it will tell me 5 times what decimal will give me 48, which for this type of problem, all we care about are the whole numbers. We don't want decimals. So that's why we would just skip it if we were looking in the table. So let's look at how is this actually going to be helpful in the simplifying radical process. So being able to do this is going to be an important part. So let's go to the next page and take a look at that. So first of all, we have some vocab here, and we're going to be talking a lot about radicals. So you guys might have seen stuff like this before with a little 3 out in front or like a little 4 out in front. And that little number out in front is called the index. So for example, this 3 represents the cube root. So it's asking me what number would I multiply by itself 3 times to give me the number underneath the root. The 4 means what number do you multiply by itself 4 times to get the number under the root. But typically for this class, we're going to focus on square roots. So square roots really have an index of 2, but because it's the most common one, we don't write that index. We just use the square root symbol. So this square root symbol is the same thing as saying radical. So if it were, let's say square root of 4, or I could call that radical 4. So you could read this as square root of 4 or radical 4. They mean the exact same thing. And again, notice that we dropped that little index of 2 just because the square root's the most common one. So if it doesn't have a index number out in front, then it's assumed to be the square root. So that's just some vocab. So then the next thing is, how do we actually simplify? So when we simplify, it doesn't mean to tell me a decimal as an answer. So if I have the square root of 4 and I want to simplify that, it's just going to be 2 because 2 times 2 gives me 4. But what happens if I wanted to find the square root of 5? If you put that in your calculator, you're going to get a decimal. So the simplified version of square root of 5 is just the square root of 5 because you can't break it down any further. And we never want to leave these, we never want to convert these into decimals because that's always an approximation and we always want exact answers. So square root of 5 is completely acceptable. Square root of 4 though, like I said, we would break that down and we would write it as 2. So this is simplified. This is simplified. This is not simplified. And that's what we're going to look at now. So how do we simplify something like this? And what's the difference between this being simplified and this not being simplified? So the steps here. What you want to do in order to know if a square root or radical has completely been simplified is you have to look to see if one of the factors in that number is still a perfect square. So for example, if I look at 8, think about the factors of 8. I have 1 and 8 and 2 and 4. One of those factors is a perfect square. So since 8 has a factor that's a perfect square in it, it means it's not simplified. Because what I can do is I can break it down into its perfect square times its non-perfect square, and it'll allow me to simplify. So what I mean by that is if I have the square root of 8, I can break it down as square root of 4 times square root of 2 because the two factors are 2 and 8. And what I always do is I always put the perfect square first and then the non-perfect square second. So for example, 4 is a perfect square, but 2 is not. So when I break this down, 4 is going to go out in front here under the square root, and then 2 will come after. So keep in mind, 4 times 2 gives me 8. Radical 4 times radical 2 gives me radical 8. So I'm not changing anything. But now, since I have a square root of 4 out in front, that's really just equal to 2. And then the radical 2 I can't break down. There's no perfect squares in the number 2. So it's just going to be left as the square root of 2. And there's your answer. So instead of leaving something like this, square root of 8, we would simplify it in this format. Now, in order to check the square root of 8, if you put it in your calculator and get a decimal, and then if you enter this into your calculator and get a decimal, the decimal should match up exactly. But these are exact values. This is not simplified, where this one is simplified. Now, if you look at the square root of 5, I said that this is simplified. Now, it's simplified because think about the numbers that go into 5. It's just 1 and 5, and neither of those are perfect squares that we would use to break this down. So that means it's already simplified. One other thing I want to make note of, 1 is a perfect square, but if I break all of these down using 1 and itself, the number, it's not going to be helpful at all. It'll basically just get you back to where you started. So let me just show you quick what I mean by that. So if I had 8 and I broke it down because I said, oh, 1's a perfect square. Well, 1 times 8. What happens is I get 1 times the square root of 8, which equals the square root of 8. So see how I didn't really do anything? So that's why we don't ever use 1. We basically just kind of always reject those factors. So in order to be not in simplest radical form, we have to look for the largest perfect square and then break it down using that. So let's try some more of these examples just so you can kind of see the process here. So for 48, we want to think about what numbers go into 48. So if I flip back to the previous page here are factors of 48. Well, we know that 4 and 16 both go into 48, and those are perfect squares. Now, in order to simplify this in one step and not have to do a second step, you always want to use the largest perfect square. And we'll look at an example where we don't use the largest perfect square just so you can see what happens. But for this first one, let's just go ahead and make it a little bit easier and say we're going to use the largest perfect square. So 16 times 3, where 16 is the largest perfect square, 16 times 3 is going to give me 48. So that means over here, I'm going to take 48 and I'm going to break it up. So it's going to be perfect square, non-perfect square. So it'll be 16 here and 3 here. And when I square root 16, I get 4 square root of 3. You just keep. So that's the same as the square root of 48. It's just this is in what we call simplest radical form, where this is not, because the 48 still has a perfect square in it. So then let's try some more. So the next one here, 72. Okay, so go back 2 pages and look at our factors. So if we are looking at our list of factors here, I would want to use the largest perfect square, which would be this, 2 and 36. So I'm going to rewrite this, and I'm always going to put that perfect square in front. So it's going to be square root of 36, square root of 2. So this is going to end up being 6 square root of 2. So I always say put that perfect square in front, because then what happens is that's going to come out to be the whole number, and then you just carry down the radical part. So that's kind of why I do it in that format. So now we have an example where we don't already have the factors. So what you can do in your calculator, or by hand, you can just come up with all the factors. So by hand, you would list out all the numbers that are factors of 75 and then choose the largest perfect square. Otherwise, my preference is to go into my calculator, type in 75 divided by x, and that'll tell me all of the numbers that multiply to give me 75. And then what I do is I go through my list and I look for which number is the largest perfect square. So, and again, I'm looking at only the whole numbers. We don't want any decimals here. So I'm just looking through my list and seeing which number or which pair of numbers has the largest perfect square. So you should find that 25 would be the largest perfect square that goes into 75. So 75, or 25 times 3 would give me 75. So I would break it down, perfect square, non-perfect square. So 25 times radical 3. So that's going to give me 5 radical 3 when you reduce the 25. Notice I dropped the radical because I'm actually taking the square root of 25. So it's asking what times what gives me 25, which is 5. Square root of 3 I just keep as is because you can't break that down. It would be a decimal if you try to simplify it. So then the next ones have a number out in front. So it's not just looking at the square root of 45, we have a 2 out in front. So notice that it's like whenever you have like an x, like if this were 2x, the operation is multiplication. Same thing goes for radicals. So there's really a multiplication between both of these. So this is saying 2 times square root of 45. So what I'm going to do is I'm just going to kind of carry that 2 out in front, and I'm going to have my perfect square, non-perfect square. So again, you can enter this into your calculator in the graph part, 45 divided by x, go to the menu, then hit table, go through the table until you find the biggest perfect square. So you should find 9 and 45, or 9 times 5 will give me 45. So square root of 9 comes first, square root of 5 comes second. Again, carry that 2 down. Remember the operation's multiplication. So at this step, when I take the square root of 9, I get 3. It's multiplication between these. And then I carry down the square root of 5. So now the last step is to actually multiply these. 2 times 3 gives me 6, square root of 5. So let's look at this other one here. So 3 times the square root of 32. So again, that 3 just stays out in front. Think about the largest perfect square that goes into 32. So I'm thinking 16 and 2. So when I do that, you end up with 3. This will reduce to 4. Keep the square root of 2. Remember, it's multiplication between these, so it becomes 12 square root of 2. But now it's saying, well, what happens if we use 4 and 8? So what if I didn't use the largest perfect square to figure out my two numbers here? What if I used a smaller perfect square? So for example, 4 is a perfect square, but it's not the largest perfect square that goes into 32. So what happens then? Is it wrong? So let's take a look. So if I start with the same problem here, but let's say I didn't think about 16 and 2 as being factors that go into 32, with 16 being the largest perfect square. So let's just say that I did this and I said, oh, well, 4 is a perfect square and 4 goes into 32. So what if I did this? What if I said 4 and 8, where 4 is my perfect square and 8 is my non-perfect square? So remember, multiplication, so it becomes 3 times 2 times square root of 8. So this becomes 6 times square root of 8. Now, right now, you should see these are not the same answers. But this is not simplified yet. And the reason why it's not fully simplified is because this 8 still has a perfect square in it. So that just means instead of being done at this point, I have to go another step further. So that means I'm going to keep the 6 out in front. And now I'm going to look at how do I break up this 8? Because 8 has factors where one of them is a perfect square. So for example, 4 times 2 gives me 8, and 4 is a perfect square. So now I would break it up as 4 in front, keep the 2. So 4 times 2 gives me 8. Now I simplify this. So remember, multiplication between those. Square root of 4 is 2. Keep the square root of 2 because that doesn't simplify. So then I get 6 times 2 gives me 12. 12 square root of 2. So now you can see that you do get the same answer. It just took that extra step because we didn't find the largest perfect square to begin with. So is it wrong not to use the largest perfect square? No, it's totally fine. You just have to pay attention, though, in the end, that radical that you're left with, you have to make sure that it doesn't have any more perfect squares as factors. So if you got to this point and you get something like 8, well, 4 goes into 8 and 4 is a perfect square. It just means you have to do an extra step. So it's not a big deal. It's just don't forget to always look at that number at the end. So like going to this one, square root of 5, I knew I was done because square root of 5 doesn't have any perfect squares as factors. So just always check that. So let's go to the next page and look at a couple that have some algebraic type symbols in it. So for this one, we still have a 2 out in front, but now we have some algebra in here. So if you look, you want to kind of treat this the same way. So we're going to have your perfect squares, non-perfect squares. So when I look at this, 4 and x squared are both perfect squares. So what ends up happening for this one is I can just go right to reducing it. So basically right to taking the square root. I don't have to break this one up because 4 and x squared are perfect squares. So what ends up happening is you get 2, take the square root of 4, you get 2. Take the square root of x squared, you get x. Because remember, square root of x squared is saying what times what gives me x squared? Well, the answer is x. It's essentially like thinking of it as dividing the exponent by 2. So 2 times 2x would be the answer to this. Just multiply the 2's, so we get 4x. Remember, this 2 here came from out in front because the operation's multiplication. If you look at number 7, though, 18 is not a perfect square. So what we're going to do for this one is we're going to keep that 3 out in front and we're going to break this up. Perfect squares are going to go first, non-perfect squares are going to go second. So I'm going to start with one thing at a time here. So 18, think about what perfect square, the largest perfect square that has, that multiplies by something to give me 18. So 9 would be that number. So 9 times 2 would give me 18, where 9 is the biggest perfect square. X to the 4th is a perfect square because x squared times x squared gives me x to the 4th. Y squared is a perfect square because y times y gives me y squared. So my biggest perfect square, or all my perfect squares are here. Non-perfect square is just going to be square root of 2. So when I go to simplify this, I'm going to keep the 3 out in front. Square root of 9 becomes 3. Square root of x to the 4th becomes x to the 2nd. And then square root of y squared becomes y, and then keep that square root of 2. Make sure you don't forget the square root because it is important. And then 3 times 3 gives me 9, so it's going to be 9x squared y square root of 2. And then the last two here, 8 and 9, these ones are a little bit different because this is basically like saying what times what will give me x minus 2 quantity squared. So the answer to that is just going to be x minus 2. So when you have an entire expression in parentheses that's being squared, it's asking you what times what gives me that quantity squared. Well, it would be that quantity, x minus 2. So the answer to this one is just x minus 2. You can almost think of it as like the square and the square root. They undo each other. They cancel each other out. So same with this one, since the whole quantity underneath is being squared, it's asking you what times what gives me x plus 3 to the 2nd. So it's saying what times what equals x plus 3 to the 2nd. Just like this one, this is saying what times what gives me x minus 2 to the 2nd. Well, the answer to that would be x minus 2, x minus 2. The answer to this one would be x plus 3 times x plus 3. So that means the square root of this quantity is x plus 3. And again, think of it as like squaring and square rooting. They cancel each other out. They're opposites. So they undo each other. So for what I want you guys to do for the remainder of class, I want you to work on the classwork. So finish these problems up before you leave. And then when you get done with those, if you look at this next page here, there's an exit ticket. So you're going to just rip this part off, put your name on it, and turn that in because I want to see how well you guys did with this. So first step is going to be to do the classwork. So there's those 6 problems that shouldn't take you that long. And then do these 2 problems, rip this off to turn in, keep the rest of your note packet, and we'll go over those next class to make sure that you guys got the hang of it. And then you have a worksheet for homework. All right, and I will see you guys next class. So have a great weekend and good luck with the classwork and the homework.